I am going to tell you a story. I am going to tell you a true story, the story of how and why we migrated to Terraform Enterprise. Let me introduce briefly myself. I am Horacio Gonzalez. As you can maybe hear if you listen, I am a Spaniard living in France, so my English accent combines the worst traits of both Spanish and French accents. Sorry about that. I am the Director of Developer Relations at OVS Cloud. I don't know if you know OVS Cloud. We are a cloud provider, a global one. We are in the top 10 in the world. We are the only European in this top 10, but we are way smaller than our friends from Google, Microsoft, or others. We have customers all around the world, but I am not here to talk about that. I am here to talk about why we began to use Terraform Enterprise. So let's begin the story. Well, the story begins at the beginning of OBS Cloud. We are, from the first day, an industrial company. What I mean? Well, we build our servers by ourselves, by assembling all the components. We do everything from the beginning to build our servers. We build our own racks, horizontal racks, especially custom-made for us, because we use our own proprietary water cooling technology, and we put those racks in our own data center, also custom one. That means that we try to master all the industrial value chain, for building the servers, to deploying them in the data centers, all that all around the world, from our factory in Roubaix, in Croix, in the north of France. Well, OK, I am here to talk about Terraform Enterprise. I guess you are thinking, hey, why are you telling us this story? Because it's very important. I mean, we have an industrial culture, and all the enterprise shares this culture. For example, for a lot of years, we have built our desk by ourselves using a laser cutting machine to cut and build the desks. So our software developers share this culture of we do everything by ourselves. We believe in open source. We use a lot of open source, but we believe also that for most problems, we can solve them by ourselves. So we have built everything in our information systems on this base, open source and building by ourselves. Let's go back to 2014. We had a lot of different teams that were deploying lots and lots of different infrastructure in three main targets. OpenStack for all our public cloud and our virtual servers. Bare metal, because it is our original business model, and we have hundreds of thousands of servers. And VMware for our private cloud. And all these different teams were using different technology to deploy. A lot of bash scripts, some Perl things, Python, and whatever. Custom-made things, most of that. And in 2015, we said, hey, we need to industrialize that. We are beginning to be too big to allow every team to do it by themselves. We have some dependencies. It is very, very complicated. So we decided, as it was in our culture, to build by ourselves our deployment as a service tool, DaaS. Well, the idea was to have a single tool to deploy everything in our three main platforms. We put a team to do that. They worked from 1 year, taking feedback from all the other teams, and beginning to build a tool, deploy as a service, DaaS. Well, let me tell you the story of how it went. Spoiler, it didn't end well. At the beginning, it was sample. We wanted a tool with a web user interface and some API that allow us to pilot all the deployment scripts that allow us to talk to our 3 main targets. We wanted the web UI to be sure that we also could have a global vision of what we were deploying and also have some notion of dependencies of who can do that and some API to allow to connect everything, especially our source repository, to this DAS. Hierarchy loved the idea of having such a tool because they had metrics. So they were able to see how many deployments were done, how they went, and all that. So they pushed for adoption. And very, very quickly, it began to be the de facto official deployment tool. De facto because it wasn't compulsory, but there was a social pressure, if you know what I mean, in order to migrate as many teams as possible into DAS. It was fully custom-made, made specifically for our needs. So we didn't use some concepts that were normal. We created our own concepts. We had 3 backends. We have the clusters that were inside the clusters. We had groups of applications, and this application could be something like a load balancer or an AP group database. And for every group, you have some instances that you were going to deploy. It was right for us at 2015. That was the first part of the problem. We had built a thing for our needs at a specific time point. We didn't use infrastructure as code. We were using mainly some script that did API calls and some API calls in the input side too, in order to make everything work. For example, if we wanted to scale a database group in that cluster, we had to do from the tool some API call, and then that will call the script that will scale the database group to that number of instances. It worked very well for us. Well, it worked very well, but it was a small team for a big project, and a company that was growing up really fast. So they began to need to deal with, hey, I need new features, hey, I have a weird error, hey, you promised me you will track this problem, how can we do? And it begins to evolve in a not very ordered way. We had need, we added things. Another problem we had is that it was a small team because it was a proprietary technology. We couldn't find some talents who will join the team. We need to combine people to use a proprietary technology to learn a new thing that they wouldn't be able to use in a later stage in the career. And what happened? Well, I guess many of you already guessed the next step. One by one, the people left the team. And new people didn't want to go in the project. So, hey, it is our own project. You need a new feature. Here you have the code base. Please do a commit, a pull request. It worked like that for 2 or 3 years. It was a living dead project. It isn't easy because all our deployment was working over a dead project that is still working. No evolution, no ownership. So, in 2019, hey, I see somebody understands the reference. That's nice. I feel less old now. So in 2019, a new team arrived. OK, now you are the owners of DAS. What are you going to do? They analyzed things. They took some time. First thing they saw the code was obsolete. It has been done for years in a not very clear way. We have some Python 2 and Python 3. We have some obsolete libraries. The UI was Angular JS, the first version of Angular. OK, so the idea is it is going to be hard to make it evolve to something sane. The architecture was complex, mainly because it was made for this need, and now the need was that. And everything has been built in order to transform the initial need to the current one. And it didn't scale. We had a scale that we have a size that it was 3, 5, 10 times the one when the project began. So, and with the complex architecture, it wasn't easy to find all the bottlenecks and try to solve them. It wasn't easy to distribute the architecture. So they decided, hey, we need a solution. Well, we are OBS Cloud. So the first thing is, hey, we are going to build the HAS 2.0. But this time, technical teams said, no, please, not again. It is going to take 1 or 2 years, and then you are going to have the same problems. We are a very technical company. We can build very, very complex things and do it well, but it isn't our core business. Our core business is to be a cloud provider and to build cloud services. Doing a deployment tools, it is going to divert a lot of resources from other tasks. And at this is a core business, we aren't going to put all the people power in order to maintain it. So the new team understood the problems. And, well, they decided to ask people what they need. The idea was, we don't only need to deploy in 3 targets. Right now, we are using many other things. There is Kubernetes. There is a lot of other platforms arriving. We want it to be very flexible. We want it to be configurable. We don't want to put the hands in code in order to make some custom things. It needs to be extensible, to be able to add a plugin if we need to add new functionality without having to rethink the whole architecture. And we need it to be some community standard, because we need to be able to find people who want to join the team. Because, hey, if we are tracking our current need and we are doing something for our current need, we will have the same problem in some years. If we use a market standard that is used for many different companies, it will be easier to be sure that it suits our needs. And they, well, do you have a tool for that? And all the teams suggested Terraform, because most of them had already used it for a small project, for their own deployments, because it was a market standard. Not the only one, but one big market standard. Then the idea was, well, everybody says Terraform. Why not? We are going to build the HAS 2.0 on Terraform. And they analyzed, in fact, Terraform was really better for our original needs than our own solution. Why? Because the extensibility, because there were hundreds of providers, because you can easily add a new provider, a new resource, a new plugin to make it work, because the dependencies were way better managed than in our own solution, because, hey, you can distribute it, the scalability wasn't a problem. Oh, let's go. Terraform is the solution. Well, Terraform is a binary. It works really well if you have one team with one deployment owner. That's nice. But if you have 30 teams with 150 people doing deployments, you are going to need to add some things to Terraform. You are going to add some airbag and rule system to be sure, hey, you can deploy this, but not that. Or this critical application, you cannot deploy it in the weekend or during holidays, unless you have the administrator role and you take your responsibility. We needed also some dashboards, because bosses love to have some metrics, some dashboards, some graphics in order to share that everything is going well. We need to have the notion of collaboration, because there are many people deploying in the same infrastructure, different parts. So we will be able to see that if you are deploying that and I am deploying that, we don't want to have a conflict and deploying incompatible things. We need all these things. So our first reflex was, OK, we are going to use Terraform as base and build everything around. Well, that's the kind of IT project that nobody wants to track. There are so many potential pitfalls, and we were back to the original problem. We are going to build a Frankenstein. We are going to maintain that Frankenstein. We are going to be forced to follow Terraform evolutions in our Frankenstein. Back to the original point. We said, hey, we have already a tool that can do that. We have a CICD project, open source, made where our teams and big contributors, CDS. Nice, we are going to use that. It is going to do many things. Well, we are still needing some integration glue. It is a solution, but not a very optimal one. It is going to take time and resources. And then somebody say, hey, there is Terraform Cloud. Maybe it is the idea we have all the power of Terraform, all the openness of Terraform, but in a managed way with pretty dashboard and with all the rights management we wanted. It could be well, stop. We are a cloud provider. We are a European one, and for us, things like data privacy and data sovereignty are very important. We needed to have something that we could deploy ourselves in our data centers to be master of all the things. So we decided to discuss with HashiCorp. And then they say, hey, your needs seems good for Terraform Cloud, but you have the hosting problem. Why wouldn't you try our Terraform Enterprise? It was kind of new at the time. People in our teams didn't know, but the idea seemed interesting. We wanted to use Terraform. We wanted to be open source based. But for all the tooling around, well, using Terraform Enterprise was maybe a solution. We worked with HashiCorp people to do a POC, a proof of concept, and some workshops. The idea was to be sure that it was a good fit for our needs, but also it was easy to learn, because if we were using Terraform, it was to have an easy onboarding of people, because most SRE already know Terraform, so we wanted something that if you know Terraform, it was easy to learn, extensible. We wanted something collaborative, allowing our team to collaborate, secure, and we wanted to be sure that at any moment we could fully understand what had happened with our deployments and what was OK and what it wasn't. At the end of the workshop, we say, hey, it's a good need. It is going to make us gain lots and lots of time. Well, many teams, to be honest, say, hey, it is expensive, but having a team of 3 or 4 engineers full-time to do that is even more expensive. So we decided to give it a try, to begin with a POC, with one team POC, and then began to gradually scale up. We decided usually not to put a lot of pressure in team. We wanted to have one pioneer team that talks with others, having a gradual adoption, a steady one, a solid adoption. So 1 team, 3 teams, 5, and for every team, we wanted to be sure that we get the feedback, allowing us to also build things that could be missing, like some providers, some resources, to be sure that everything went smooth. Today, some numbers, they are from last week, I think, 2 weeks ago. We have 16 teams already using Terraform Enterprise, some 800 workspaces. Every workspace is an application on one environment, I could say. We have a weekly of almost 2,000 runs every week. And a normal week, we are between 100 and 110 users deploying things. It is extensively used by our teams. They are really happy with the idea of having the tool. They are really happy with the visibility they get. They are using it for manual deployments, for automatic deployments. They are also using it to see potential evolution when they change some files, seeing the plan, seeing everything is OK. It's a cornerstone today for this team's deployment process. We are happy with the tool, and we are investing time and energy to make it even better for us. We are adding it to our official onboarding training for SRE, DevOps, and sysadmin people. We are adding more and more documentation of how we do that. Why? Because we are a cloud provider and we build ourselves our infrastructures. So we are using some custom providers, custom resources, and we want it to be heavily documented in order to make new teams don't have to do everything by themselves on their side once again, to be able to take profit from the collective experience we are building. We are adding some tooling to have even to simplify, for example, the management of our bare metal park and seeing what is the interfacing these management tools with Terraform Enterprise to be sure of what are deployed in what server, in what rack, in what data center, and all that. The big challenge for us was to write the providers needed for our custom infrastructure. Right now, we believe that the best thing is when a new team arrives to Terraform Enterprise, to work with them, to be sure they build their own providers, their own resources, their own specific, for their own specific needs. We also need to be, we are working our security teams to create a provider for our security infrastructure. And we have some teams that are deploying on hundreds and thousands of servers. So we wanted to be sure that the global infrastructure could support the load. We are building agents that will absorb those big teams' load. The idea is we are building tooling to be sure that it works smoothly with our infrastructure. And that tooling, it isn't tied to Terraform Enterprise. They are Terraform resources, Terraform provider. So we are keeping our open source first spirit. We are using Terraform Enterprise to do all the heavy tooling to make it go smooth. And what the teams think of that? Well, spoiler, they are quite happy. I have the feedback of some teams. I was last week bothering everybody. Hey, I need some questions. That's are the teams currently using. As you can see, there are some things that are core infrastructure, other teams that are deploying final products like web hosting or web cloud databases. We have people doing high-level projects like machine learning and AI, and people doing bare metal infrastructure. All of them are using Terraform Enterprise today. The original team that built it, they are mainly using it to deploy infrastructure, virtual machines with vSphere provider, and bare metal with our own provider. They are also using Terraform to integrate everything in a CMDB, because that was a problem. How we industrialize our CMDB? Why? We can also call the API after every deployment to be sure that the CMDB is up to date. They are really happy because it is flexible, because they can do everything they want. The only problem they have, they still don't have a provider for all the internal resources. Right now, it suits 80 or 90% of their needs, and they are still working for the very specific things, updating their provider and all that. Another very different team is the data convergency team. They are deploying data analytics tools in custom Kubernetes clusters. And they have many people working at the different stages of deployment. They decided to do a very interesting way to deploy. Every step of the deployment, it's its own workspace, from managing the environment, to managing the virtual machines on OpenStack, to set up Kubernetes, to deploying the public Helm chart or our custom-made Helm chart. Everything is a different workspace, and they are using data remote state as dependency tool. It makes things easy for them. It's one example of how they have custom adapted everything to their own needs. They are happy. They are really happy. Well, they say that the way to manage everything with a workspace have some problems. It is more difficult to see a global view of the deployment. And of course, as the other team, they still have some internal resources that aren't well done in our internal providers. So there is still some work to do with our internal providers. And the web hosting team, well, they have today some thousands of servers. Their target is to deploy 20,000 servers with Terraform Enterprise. They deploy mainly infrastructure, but many different kinds of infrastructure, from virtual machines to bare metal to Kubernetes clusters to VMware vSphere. And they deploy it everywhere around the company using using the bare metal provider, our bare metal provider, using the vSphere, using OpenStack, doing it by hand and also by API. The first thing they told me, hey, the onboarding is really easy. And now we can find people who don't mind to take some time to learn the deployment tool. Hey, it's Terraform. It is something proprietary. It is well documented. And Terraform Enterprise makes things easy. For them, it is very important, the community support. In the bad side, well, they have too many workspaces for all those servers in all those environments, in all those data centers and all that. And of course, you see, it is the feedback of everybody. If you are doing something and you are very custom infrastructure, you are going to need to spend some time working in your internal providers and resources. It isn't a blocking point. They can do almost everything. But this is a pain point that we are still working to fully solve. The advantage, we are developing everything as Terraform providers. We know that we are working in something that we can reuse every time. So it doesn't mind us to spend some time to do it well. And I think, hey, wonderful. I have no more time, so it is everything. I hope it has gave you an idea of why and how we choose Terraform Enterprise. And if you want to discuss, I will be there for the next half an hour. Thank you very, very much.